Welcome back, everyone. Now we have an interview with Professor Dov Dori, who is the inventor of Object Process Methodology, OPM, which many of you are familiar with. If you're not, it's a great thing to learn so that you can better model and by that way design and also understand various systems. Dov Dori has been working on it for the last 30 years. We really go into the origin story of OPM back when he was using a whiteboard, sketching out the idea, and then that full journey right through to the ISO standard. We touch on many things, including the ISO standard, which I've got in my hand here, which you should definitely take a look at if you really want to get into a deep dive. But we also keep things at a more rudimentary level and the real foundations as to what OPM was built on. We look at the books, the Green Book, which many of you are familiar with, for 2002, the real originator, and then also a later edition, the 2015 Model-Based Systems Engineering with OPM and SysML. I actually have 2 copies, very good. And as ever, there are PDF notes. So if you, in addition, you want to read through this or separately, just download them. I've got them in my hand here. There's a link below where you can get those. So yes, many things. And then we look into the future. So using AI, LLMs with OPM, various projects Professor Dov Dori has, and applications, including in medical research. So yeah, really hope you enjoy this, get those notes, and of course, leave comments below. Okay, so I'm here with Professor Dov Dori, the creator of OPM, Object Process Methodology. How are you, Dov?
Very good, thank you.
So for someone who's just come across this immediately, maybe on YouTube, what is Object Process Methodology?
Okay, so Object Process Methodology, or OPM for short, is, as the name implies, a methodology, but also a language for modeling systems of whatever kind. So it's based, again, as the name implies, on 2 simple building blocks, which constitute actually the ontology of the whole world. These are objects, things that exist or might exist physically or informatically, and processes, which are the things that transform the objects. And by transforming, I mean generating or creating new objects, or consuming existing objects, or changing the state of an existing object. So the objects exist, but their state is changed by the transformation. So transformation is a 3-pronged operation, if you will. Creation, consumption, and state change of objects. And that's actually, as we say, standing on one foot is the whole theory underlying OPM. Of course, there are more features like the bimodality. So OPM is both visual and textual. It has one kind of diagram, by the way, unlike other modeling languages like SysML and UML, which have 9 or 13 kinds of diagrams. Each, in fact, is a language in its own right. OPM has just one kind of diagram, and it translates on the fly to OPL, Object Process Language, which is a subset of English. Every sentence in OPL is a legally, syntactically correct sentence in English, which expresses in words what the graphics expresses in pictures. So this dual modality caters to the dual channel processing of humans who process information both visually through the visual channel and verbally or auditorially, if you will, through the language channel. And every human being has their own preference as to whether they are more visual or more textual.
Great, thank you for that. And as a person, I remember 10 years ago, I stumbled across OPM. My professor actually, he put a copy of this book, your book. This is the 2001, I think, book, 2002 book.
Oh, yeah. And there is another one from 2016.
Which is this one, the other one. I've got my tabs in there. I've been swatting up recently. And I remember what I thought was so incredible with OPM was that while the book is thick because there's lots of examples, actually maybe the first couple chapters or 3 chapters, you're grasping what felt like to me 80% of what really mattered, and that everything else was addition. And so you could, so often with these languages of any type, even Chinese or Python or anything, you can feel like you can't really go anywhere with it until you've spent maybe a month studying the language. But with OPM, you can essentially almost immediately, like almost probably from what you've just described, plus knowing what the symbols look like, be doing stuff productive.
Yeah, indeed, this is one of the strengths of OPM, is the simplicity of the basics. Of course, if you want to express complex systems and things like conditions and timing and so on, it gets a little bit more involved, but basically it's really dealing with objects with states and how processes change them. And also the software that we built, OpCloud, is very intuitive, and it also almost provides you with means of generating OPM models that are correct by construction, because it won't allow you to do things that don't make sense in OPM. And if you do something that is a little bit problematic, it will flag and ask you whether this is really what you meant.
Yes, and I'll give a link to OpCloud in the description because it's a great place to play. Like you can, while learning OPM and later when you're doing full modeling, it's a great place to play, and you can very quick, you literally like type in the URL and you're going and you can build a model.
We give it away for free for academia and non-for-profit organizations who work with it. And organizations like ISO and INCOSE get access to it, as any university worldwide. And there are about 60 of them that use it for teaching or research.
Wow, yeah, that's great and kind of you. So so often very simple things don't come from a simple place. What was the origin story of OPM, and was there like a moment where you realized actually we could model essentially everything with such simple input?
Okay, so the story goes back to the early 1990s. I was sitting with Professor Robert Harlick, who at the time was at the University of Washington in Seattle, in my office in Israel, and together we were trying to model a system for a proposal for NSF that we were preparing. And at that time, the object-oriented approach of modeling with objects was becoming very popular. And so every object was represented as a box, and there were links, lines connecting the boxes. The topic was understanding engineering drawings, but that doesn't matter. So the blackboard or whiteboard started filling with boxes and links between them. But then it dawned on me that actually about half of the objects, so-called objects that are there, are not really objects. There are things that do stuff, that they don't exist, they operate. They operate on the rest of the boxes. And then I started marking them with circles, and that's how circles or ovals became the symbol for processes, while boxes remained the symbol for objects. And then from that, when I started realizing that actually the object orientation story is just half of the glass, the other half is what happens with these objects. The object-oriented approach solves this by things called methods, which are things that the objects can do. But many of the processes cannot be really affiliated with just one object, because they involve a number of objects. Some of them are consumed, some generated, some just serve as instruments that they don't change themselves, but the process will not happen without them. And it is very awkward to do this in object-oriented approach with methods, because methods are quote unquote owned by particular specific objects or classes of objects. and you don't have something like a process that involves directly more than one object, and that makes modeling awkward. For example, if you want to model a caching of a check, you have to make caching a method of check, but the caching involves the owner of the check, the clerk in the bank or the ATM, and the money that gets in return for the check, and all that cannot be modeled by the check itself. So what by enabling processes and bona fide things in as a building block in the model, all of a sudden you can do a lot of things much more naturally than you can with the object-oriented approach.
Yes, yes. So it was coming from, you were doing information modeling and sort of discovering that your objects, it's incorrect to say that every process or every method can exist within an object. As you said, with a check, like a physical piece of paper, that cannot contain the entire banking system. Like that, those are all these other. Yes, okay.
And then I realized that it's not just for information. Indeed, in the first couple of years, I thought it might be good for modeling information systems, but gradually I realized that this is actually true for any system that contains both physical and informatical, or if you want, cyber-physical things. And so I gradually drifted from information systems engineering to systems engineering, and this is how I became more affiliated and interested in systems engineering per se, and not in information systems engineering, which can be considered, even by its name, as a subset of systems engineering.
Yes, yes. And so many things, well, even physical things now have so many information aspects and internet connectivity and things. It's kind of the boundaries are becoming blurred, or everything's kind of becoming the same thing.
Right. Actually, from the beginning, you cannot distinguish quote unquote pure information systems from non-information systems, because every physical system contains information. It cannot have control or operation without some control element, which by definition is informatical. So this is true for biological things and for inanimate systems, anything.
Yes, yeah. Actually, there's one analogy I sometimes use when I talk to people at OPM who don't understand it or struggling to understand. I say, well, with Lego bricks, you can build let's say a small toy car type thing. And we can see those bricks, but all the behaviors that Lego toy car can exhibit are, maybe you have them in your brain, you can look at it and see them, but with OPM, we can explicitly describe them along with those Lego bricks. And
actually, objects and processes can stand for the structure and behavior, which are the two major aspects that any system has. And it also fits well with the space-time notion of Einstein, that in order to describe the whole universe, you need to have a four-dimensional space, which are the three spatial coordinates and the temporal coordinate. And the three spatial coordinates are for the 3D object, and the temporal coordinate is represented by the processes, and they interact with each other. And that is actually almost a proof that objects and processes are the basic building blocks, and they are necessary and sufficient building blocks for specifying systems in the world and phenomena in the world.
yeah, and it's so good as well that OPM, like, you thought about these topics and how it intersects with sort of fundamental physics, as opposed to, so often with especially information modeling languages, they're sort of built up on software coding as opposed to the reality of the universe.
Right.
So your journey, my feeling is OPM has been sort of developed for 30 years, like looking at your papers from sort of the late mid-1990s, early 1990s, the Green Book, 2002, and then ISO standard in 2015, and we're recording this in 2025. How?
The standard was recognized as an international standard only last year in 2024. The 2016 was a publicly available specification, and it took a number of years as per the ISO directives for it to be rendered into an international standard, and so only last year it became a bona fide international standard, 19450.
Okay, wow, yeah, I didn't quite realize that. And actually, this will be interesting. Like, what is it? Because I remember reading what I thought was the ISO standard in 2015, but yeah, clearly that.
Yeah, they're actually the same. It's just a matter of formality for it to undergo this 6-year period before it became, so it became a publicly available specification, PAS, in 2019. Yes, and 18 and 6 years later, last year in 24, it became an IS, an international standard.
So do ISO just require like a kind of period of time for, I guess, people to object or make?
Yeah, and actually we plan to issue a new version. It will take some time because there are many features in OPM that are not included in the ISO 19450. For example, all the aspect of computations that we can now do, and it's doable in OpCloud, and that is not included as part of the standard.
Okay. So the standard is, let's say, the basics of OPM, but
the standard focuses on the qualitative modeling, conceptual modeling, but OPM has been expanded with the ability to incorporate in the same model both conceptual and computational aspects. So you can have numbers as values of attributes of an object, which is physical, and then carry out processes that are actually mathematical formula or computer programs that take numbers as parameters, which are objects as inputs, and outputs a result, which it computes. And then in a simulation, you can, based on the result, you can make decisions and go on. So it's a mix. We've written several papers on this and send you references that show and demonstrate how this is done.
Mm-hmm. Okay, so you could almost build like a primitive calculator from an model.
Yeah, it's nice that you don't need to move once you are done with the conceptual modeling. You don't need to move to another realm or paradigm. You simply naturally flow. You use your model and you inject into it computational aspects based on the foundation of the qualitative model, and that refines it. It makes it more accurate, more close to the implementation level that detailed design requires.
And so I was thinking, from when you originated OPM to today, the world has changed a lot. People suggest AI and connectivity and all these new technologies. Has that what influenced your additions to the language or other matters?
Actually, the addition of the computational aspect was done before, the burst of the generative AI in the last 4 years. But it started almost just before it. But we do actually have incorporated AI into OpCloud. So with current OpCloud, you can ask a large language model, which is connected and embedded actually into OpCloud, to take a piece of object process language sentences, what we call OPL script. And even though every sentence in OPL makes sense in English, the order is not necessarily very logical. And what the LLM does, it takes and it gives you, it digests it for you in a way that is much more approachable to humans, And we have this feature, and it works very nicely. So people don't need to read the OPL, they read the interpretation of an LLM, which is based on the OPL. Another work that research that is undergoing, it's a PhD research of one of my PhD students, is to take natural language text and generate from it a OPM model. And this would be very nice for many applications, such as building an initial system model from requirements document, or taking a bunch of scientific articles on a specific topic, like the structure and operation and behavior of a neuron, and generate a very big OPM model of it. I'm doing it right now manually, and I'm fascinated by it. But the vision is that in the future, we will be able to do this almost, or at least 80% automatically. And so that will provide the ability to have an ever-growing and evolving knowledge base that is stored in graph databases. Because as you can realize, OPM is actually a very big graph that is built on hierarchies. We have an algorithm for flattening this hierarchy and get a very complex graph for complex systems that are modeled in OPM. Admittedly, it is very complicated for humans to inspect, and this is why we have the hierarchies. But for a computer, it doesn't matter. So you get one flat, big, complex graph that is immediately digestible by graph databases such as Neo4j, and we actually have a connection to Neo4j in OP Cloud, and we can have all kinds of queries such as shortest path and so on that work on this.
Yeah, you can build on all of that rich knowledge of graph mathematics and matrix maths and things. Yes, actually, that was when you were talking about taking natural language and then converting it into OPL or OPM. That was a question someone in the audience had, and that they could see how uniquely with OPM you have this language duality, and so they were thinking with these LLMs, that must be a narrative.
So, yeah, one of the examples we are working now is a medical question answering system that is currently purely in text, and we are building a model, OPM models from the text, and then they are used to answer questions more effectively. And we actually published already one paper on it. I can send you the reference. It was presented in Calling 2025 in January this year.
Great. And it's great that it's being used for a purpose, because sometimes with languages and language papers, they become very nitty-gritty on the detail of the language, and we forget the application.
Yes.
So what's it like getting an ISO standard? Like, it appears like especially from scratch, that it could be an incredibly challenging job.
Yes, actually, like you mentioned, it's this whole journey started in 2009 when I presented OPM in some aspect in an INCOSI conference in the Netherlands, and I was approached by Richard Martin, who still is the chair of Working Group 1 of Subcommittee 5 of TC 184 of ISO, and he suggested that we together start working toward making OPM an ISO standard, because we both were thinking that it would be a good idea that the next generation of international standard be based not on text, which can be ambiguous and incomplete and very difficult to verify. Rather, the idea was that international standards would be based on OPM models. For this to happen, we first have to have OPM as a standard in its own right. And that started in 2009. And as you can see, only in 2024, meaning 15 years later, it became a standard. Meanwhile, we started also working on model-based standards authoring, which is soon to become another international standard based on OPM on how to author or write the next generation of standards, underlying which would be a conceptual OPM model. And the text of the standard is derived or will be derived from what is expressed by the model. This way you can verify that the standard is complete, is consistent, is coherent, doesn't contain contradictions, and so on. And that is going to make a huge difference.
Yes, because I think many people they don't read the standard, or you have this 800-page document, and well, like with the law, you can have bills going through Parliament, which they themselves have contradictions internally, and anything that you can do to.
It is very difficult to avoid having contradictions in an 800-page document without any mechanism or ability to check, because you can write black, the sky is black in page 13 and the sky is blue on page 754. Go find it. I mean,
yeah. And then have a footnote, but only under certain conditions, and then those conditions. So once you model it, and that model is itself no internal contradictions, then you have a much higher likelihood that there aren't contradictions within that.
Not only do you model it statically, but in OPM you can also execute it. So you can actually find contradictions or deadlocks in the execution of what is being described by the text. And that happens quite often.
Do you have a target area where you think could be the first ISO standard to be modeled in OPM?
So we think about modeling requirements, documents, because this is the most straightforward application. But my vision is to actually convert all the biological and medical information that is stored in hundreds of thousands of papers in PubMed and the likes. There is so much information there that can be much more accessible and much more connected when it is translated into an ever-growing OPM model that makes connections with seemingly disparate factors or objects that they can point to things like remedies or finding solutions and for diseases that are currently incurable. So and this is all doable, and we are working toward this. Another thing, which is another PhD research, is based on an OPM model, find and mitigate risks in the system. So the idea is to look at every process that is modeled in the system and examine what we call the pre-process object set, the set of objects that is required either as consumees or as instruments or as objects that change their states. And for every such object, ask what can go wrong if that object doesn't exist or that is not in the required state. And then, okay, say what is the severity of this object missing or not in being in the state, and what do we do to mitigate it by incorporating or augmenting the system by a mechanism that ensures that those objects that are required are there. So that's another avenue of research that we are currently doing.
Thank you. And so one challenge I see with modeling in general is people want to maybe keep adding to their model, keep adding many, many things. And what I often encourage them, or I say, we can keep adding things to the model, but at some point it is becoming cluttered isn't quite the right word, but it's becoming unhelpful. Do you find that as well, that people, they want to, oh, this is a thing there, so let's add it on, but they're not sticking to like, what is the purpose of the model and what is it communicating?
Right. So for systems engineers, my advice is to get to the level of detail that is sufficient for detailed engineering for the various verticals, for the electronics, the software engineer, the mechanical engineer, the human factors engineer, that they understand how the system is expected to operate and function as a whole, and there is enough detail for them to start doing the stuff and how to interface with the other disciplines. Once this level of detail is achieved, you can stop. And so the idea is to really provide a model that is detailed enough for the vertical modeling, for the vertical people, for the various disciplines to start working on them. For other models that are not systems engineering, it really depends on the level of detail you want. So like I said, for example, I am currently modeling manually with OPM the structure and behavior of a neuron in our brain. And it turns out to be, for me, I mean, this has been known, of course, by biologists, but it's like 3 orders of magnitude much more complicated than an artificial neuron. There is so much chemistry and molecular biology and things going on there that it's overwhelming. And I'm working 3 weeks on this, and I'm still discovering many new things that I put into the model.
Yes.
And the idea is later on to also model abnormal behavior and then get ideas for possible medications, for example, for Parkinson's or Alzheimer's diseases, based on abnormalities of neurotransmitter release that is due to misfolding of some alpha-synuclein, which is a protein that doesn't fold as it should be. Things like that. It gets to that level.
No, it's really fascinating to hear you doing so much work in medical and not medical devices, like in medical, like actually the human body. Like it's so often when we hear about modeling languages and things, it's always a aircraft or a railway train or something, a clearly sort of man-made artifact. So
actually, already like 10 years ago, there was a PhD student of mine that was also advised by a colleague from the Faculty of Medicine at the Technion, Moti Choder, and her name is Judith Somek. She is now a faculty at Haifa University. She modeled the biological phenomenon, and as a result, we published a series of 3 papers and found some new knowledge in biology that was triggered by the simulation of the model, which was at the time the biggest in OPM. And it raised questions that the people from the Faculty of Medicine then went to the wet lab and found some new stuff, and that was published in PLOS One already 10 years ago.
Wow, it's incredible. Yes. And I find like if there is a thing, a subject that you want to understand better, actually creating your own model while you're trying to understand it, you get a better sense of what the limits are of your knowledge on the topic area, and then seeing that can be scaled up to biological systems is incredible.
Yeah, and like I said, when I do currently the modeling of the neuron, I gather information from many sources. I get a lot of help from LLMs because I just pose a question and they give me the answer. And when I don't understand some aspect, I ask it and I immediately get an answer with resources and pointers to pictures. It's very helpful. But But that alone is not enough. You have to, because every resource gives you some aspect, but it doesn't give you the whole picture. And the whole picture is really captured by the model when I pick up pieces of knowledge and put it and gradually get a much bigger and much more comprehensive idea of the structure and behavior and how they interact.
Yes. So one quite technical question. So often system dynamics and feedback loops are often very, very important, especially when people are doing systems thinking and trying to initially get a grasp of a problem and topic area. What advice do you have for people when they know they have feedback loops, or they don't know they have feedback loops, but it's becoming apparent that they will need to be modeled in OPM?
Right. So as I mentioned earlier, we currently have the ability to incorporate computations and quantities into the model. So you can actually model feedback loops, and when you simulate them, you see how the values change over time with the loops. Actually, in a paper that was published a few years back, we show how an aircraft landing, the landing gear, behaves as an aircraft lands, and computationally you actually get an idea of what the diameter of the pipe of which the landing gear is made should be in order for it to withhold the impact and things like that. So really integrating the conceptual with the computational aspects can give you a leverage to do things like that.
Right. And so another question that the audience have is, so when they look for conceptual modeling languages, OPM, of course, comes up, but another big one, SysML.
Right.
How should they navigate what would be the strengths of either? And, clearly your book, model-based systems engineering with OPM and SysML, you've written on a book that contains both.
The book really, some people complain about it, that most of it is OPM, which should be natural, of course. But what I show in this book is that SysML it goes into details in certain aspects, because it has 9 kinds of diagrams. You can, and we have shown it in a research, that when you want to delve into a certain aspect, such as the time sequence of what happens first and next, you might do better by looking at a sequence diagram of SysML or UML, or state machine diagram. Maybe can give you a somewhat better idea of state changes. So for particular aspects, SysML might be better, but to get the overall picture of a system, you really should use OPM. And I show in the book that every one of the 9 diagrams of SysML can be done with OPM. But we also realize and recognize that this is much more, that SysML is much more prevalent in the world of systems engineering. And one of the things that we are working and is almost finished is to be able to convert an OPM model into a SysML model. We already published on it over 12, 15 years ago, but to actually implement it is going to be ready in the near future. And that will provide a way for people to take an OPM model, and if they want to switch to SysML after an initial modeling and getting to a certain level of detail, they can do it and then continue working with SysML. And of course, it complies with the SysML standard of how to interchange files and so on.
Yes. Yeah, and that fits with my experience that OPM, if you need a holistic view and be able to navigate by abstraction layer and zoom in and zoom out, as the terminology in OPM is, it's very good. And senior stakeholders have we'll give it the time of day to understand what it is. The only two diagrams I've had any luck with showing senior stakeholders to is block definition diagram and internal block diagram. Like all the others, timing, state machine, like for them, that's just like looking at a circuit diagram. Like it's just meaningless.
In OPM, you don't have to pick what kind of diagram because you only have one. What you do have to pick is how many levels of depth you want to show the senior, depending on the seniority of the management, how much time and how much energy and interest they want to delve into. So you can decide to stop after the system diagram, the zeros level as we call it, or the first SD1, SD2, which is the first level of detail, or SD 1.1, 2.1, 2.2, and so on, which is the second level. And of course, for actual, the whole system can go down up to 11, 12 levels of depth in a tree structure, in a pyramid, if you will. And so depending on the level of management or of the people working, the upper management will be naturally interested in the 1 or 2 or up to 3 levels of depth, but the people in the trenches will have to work with the lowest level in order to do the detailed modeling and detailed design.
Yes, and this is so important because it's not possible to have all the details in one's mind, and you do need a consolidated view that we make sure we haven't forgotten the big picture. So often, we go down all these detailed things, we forget what the purpose of the system is. And
and in OPM, it's really straightforward because you asked at the beginning, what is OPM? So I said, my answer was, it's both a methodology and a language. The language caters to the methodology, and the methodology advocates that you start with the system's function, which is what is the main process that the system is expected to do, who are the beneficiaries, and what is the value that they gain. And by asking these questions, you generate the system diagram and you understand immediately what the system does, for whom, and how does those who gain from it get the value. This is by changing the value providing attribute. So for example, if I want a system that moves people from one point to another, I call it a transporting system, and the beneficiary is the group of passengers, and the location changing from origin to destination is the value that they gain. All this is modeled and the system is called simply a transporting system, which could be a car, an aircraft, or any combination of vehicles. And that is all you need in the first, in the zeros level, in the system diagram. And then you start detailing how this is done and what are the components, what is the role of each component in each sub process, and so on.
Yes, and I think in the MIT Systems Architecture book with Professor Ed Crawley and Bruce Cameron, they show this really nicely.
Yes.
It's a really nice template, and I'd encourage people to look that up additionally and it's great that they were using OPM in their book, which isn't an OPM book, it's a system architecture book, but they chose to use OPM.
Yes, we've had a long history of collaboration. I spent cumulatively over 10 years at MIT with Crawley and Oli Devek and all the good people that are working there. And we still have connections, of course.
Yes, and it's great that they use it on their courses as they're not teaching it as let's learn OPM. It's like, let's do system architecture, and here is a great language that will help us do good systems architecture.
Exactly, yes.
So thinking beyond systems engineering, have you had much success with, let's say, the law or government, or I know we spoke about medical, but I often find a benefit of OPM because of the OPL, the language aspect, for people like lawyers who they do a lot of reading, you have a lot more success with OPM because they're not scared away by the diagram.
One of the ideas that we are playing with is to have an application of OPM that models legal contracts. Because one of the problems, as we talked about text documents, is to find holes or discrepancies or contradictions. And if you look at a very long contract, like a requirements document, it is bound to contain misunderstandings. But the problem with lawyers is that sometimes they do it on purpose. They make the language convoluted so that when litigation comes, they can argue one way or another. So this is quite challenging, but I still think it's going to be very valuable to have an application that, and we can have it once we have our system that converts automatically natural language text into an OPM model. Another application that is very attractive is to model patterns, because then you can have a search on patterns that is not just based on keywords, but on structure and behavior of systems. And that is going to be a different level of search and matching. When you claim a patent, you can look for patterns that do similar things and claim whether or not this is new.
Yes, yeah. So it seems OPM could be the base language for any area which currently depends on unstructured natural language, and you can turn it into something structured, but that structured thing isn't simply a database with fields and queries into those fields. It is a graph with connections between those. But of course, and people need to read the OPM book, you can then have your attributes of your objects, which then can become your parameters that define that particular object.
Right. So if you're talking about tables, you refer to relational databases, where each table is actually a class of objects, and every column in the table is an attribute in that class, and the rows are the instances, the actual objects that exist under that class, and each one has their own value. So each cell in this matrix, in this table, is the value of an attribute of a particular instance belonging to that class. But again, this is just a structure, and we have, by the way, a way of converting such table into an OPM model with the instances. The only problem is that when you have more than 5 or 6, you don't have enough real estate of screen to show all of them. So you have to show either part or not show them at all. But you don't, when you look at the tables, you don't see the behavior of the system. It's just, so this is where the connection with objects and processes comes, and the integration of structure and behavior through objects and processes in an OPM model.
Yes, and it's always tempting to display everything, but what I do like about OPM is how you can fold objects back up and then display them at the high level, and even you can I've forgotten if the term is hide, but essentially if an object or thing exists on one diagram, that is sufficient to say that it exists in my system, and I don't need to display it on everything.
You only display it if it adds to the understandability of this particular OPD. So the idea of breaking down a complex system into diagrams is the human limitation that you cannot grasp more than 5 plus or minus 2 things in your short-term memory. So you cluster them according to the place in the hierarchy. The most important things, objects and processes, are at the top level, the system diagram, as we discussed. And as you dive down, you gradually increase the level of detail, but any OPD, any diagram in its own right should not consist of more, or should not comprise more than 20 elements. By elements, I mean object processes and links. Or when people get used to it, you can put more, but for beginners, it really should look unintimidating and still have the whole information. The only thing is that you need to add more levels of detail, and so you can navigate the levels of detail and don't look as you will at lower level details.
Yes, and that's so important. As once you've got your architecture and you need to communicate, you need to be clear as to just showing everything is unhelpful. But you need to be clear on what you're showing and why.
That, by the way, happens a lot with UML and SysML models. When somebody throws at you a very complex diagram, never mind what the kind of diagram, one of the 9 or 13, people, they won't tell it to you, but they get intimidated right away. Oh, this is way over my head. I will never understand what they are trying to say. Whereas when you show something that has 5 boxes and 3 circles and several lines within them, and even if it translates to natural language, that's much more helpful. That is something that people can say to themselves, okay, I can handle this. And then, okay, you understand this, let's go to the next level of detail. And so you feed them with a spoon gradually, not throwing an overwhelming complex system at them in one shot. That is destructive.
Yes, yeah, absolutely. So one of the viewers asked me to ask you that they're an enthusiast of OPM, but they also very much study with interest Professor Adrian Bejan's work on constructual law, his constructual law, and they wanted to ask if you saw some synergies between this, in particular. I was studying it when it came in. Constructural law is the idea that systems evolve toward easier flow. And Dave was saying, well, maybe that would even predict that modeling approaches like OPM would be created because they make modeling a system easier. And I don't know if you had any thoughts around Adrian Bechan's.
There are 2 ways to look at it. One is the evolution of languages that you might think of. So we mentioned the UML, and from which SysML has evolved, and OPM, even though time-wise OPM appeared even before the first UML was introduced, but still you can think about the evolution of languages that they start complex with certain diagrams in UML, going a little bit down to 9 with SysML, and then jumping to 1 in OPM, plus adding the lingual, the linguistic, the textual modality, which simplifies or makes them more amenable to straightforward understanding. So you can think of this as becoming or making it easier to flow. The information that is being described in a system or a phenomenon is made easier to follow and understand by using simpler languages. That is one way of looking at this constructal law. The other way is what we discussed about modeling within OPM. You start with the top level, which expresses the core of the system, the value it brings to the beneficiary, and how it does it through the function, which is the combination of the main process and the main object that is being transformed. And then you gradually, by refining through in-zooming and unfolding, you gradually expose the details of the system and or the phenomenon that is being modeled, and until you're understanding to a sufficient level that you say, okay, now I get it. Or if you want to ask more questions, you can still zoom further or unfold and refine it more. But that is flowing, that is top-down flowing from the main to the details, from the main idea to the details of the idea. That's another way, because the principle talks about branching and hierarchies, and that's exactly what we do in OPM in the modeling process.
Yes, yes. And if no one's seen sort of an OPM model when they're coming across it, really you can be this really quite nice pyramid from that initial originating process, and then decompose, and then but of course decomposing and many processes coming from one process.
Right.
Now, another question from the audience was, what kind of skills or mindset are best to prepare someone to fully leverage OPM?
So the nice thing about it is that you really don't need, you just need common sense and understanding of the world and open mind. I can give you an example. At the Technion, initially, teaching OPM was something that was taught at the third year of a 4-year engineering program. But then we gradually realized that, and there were a list of programming and database courses that were prerequisites for it. But we gradually realized that this is really not really required. And so we made it as a third semester, second year course, because it doesn't really require any prerequisites, and people, even on the contrary, people come more open-minded to this than they would if they are already in the third or fourth year. In the fourth year, they use it to design and implement projects. They use OPM as the modeling language of choice in the first semester of the fourth year and in the capstone project, and then they implement it in the second semester.
Yes, yeah, and myself, I've shown OPM to people who've just finished a language degree or neuroscience degree, and they can grasp it pretty quickly. It's not, it doesn't need to be engineer people. It's just anyone who's got an interest in representing something.
Exactly, because it also is not just used for modeling engineering or technological or even social technical systems. Like I said, and if you have some time, I can even share the screen and show the current state of my modeling of the neuron. Maybe.
Yeah, just loading up. Yep, now we see the OP Cloud.
Okay, so so what I model here is not just the neuron. The neuron is the object, but what is called the action potential, which is the electrical pulse that is going through the neuron. And one nice feature of OP Cloud is that I can embed pictures. As you can see, the neuron has also a picture of it. And there is a link that I can click and it opens. Do you see it, or just no? You probably don't see it because it's not part of the application.
No.
No, never mind. It just it takes you to a place where you can read more.
Okay.
And so the process that we are modeling is action potential propagating, and it has several states not yet created and propagated. When I go into the first level, the SD1, you see it starts becoming really much more complicated. We start with the NAK plus concentration gradient maintaining, which affects the Na plus and the K plus. And when I go into this one, it shows me how this is done. This is done by the sodium-potassium pump that keeps the Na plus out of neuron transporting, so the Na plus goes from the inside of the neuron to the extracellular fluid, and the other way around with the K plus. And you can see that when I hover over the sentence at the bottom, it highlights the graphics, and vice versa. If I stand over the process, it shows me the sentence, the OPM sentence. And it goes a long way down. So for example, here is another, this is action potential initiating. It takes the integrated photosynaptic potential value evaluating by integrating it, and if there is a certain condition that is true, that triggers the action potential, which is now triggered. And you can see the other states. The number 4 here symbolizes the other state, which is when you hover over it, you see them. If you double click them, you can see them explicitly. And yeah, go ahead.
One thing, just this idea of the OPL. So if anyone's never seen an OPM diagram before or in OpCloud, just so whenever Dov or the modeler creates a new object, new process, anything, automatically this OPL is being populated. And so you can always use it almost like a, oh, I don't know what this symbol means. You can just click on it and then it highlights the text, and or vice versa. And it's so very, very helpful.
So what I wanted, you see, I told you that we now have the ability to interpret OPL by AI. So if I click on this, I am generating the story that you see on the left. So action potential. So what you read here is really a collection of sentences that are okay and understandable legally, but to make sense, to put them together is quite difficult.
Yeah.
But here is a story that was generated by taking them and making sense as a story. So action potential repolarizing. Inside a segment called SD1, a process unfolds. First, potassium ions flow out of a neuron. As this happens, the potential of the axon membrane drops. This leads the axon membrane hyperpolarizing and recovering in that order. A voltage-gated K+ channel can be either closed or open, and so on. So you see, this really reads more like a story, but it is 100% based on what you see on the left. So the idea also in remember I mentioned the next generation of international standards is going to be model-based. But we don't want to supply people with OPL. We will convert it to something, what you see on the right, using LLMs. So, but on the one hand, we know that it is based on a verified and simulable OPM model, but it is also not robotic or mechanical as an OPL, but much more catering to human storytelling love, if you will.
Yeah. And from memory, OPL, there is no order to the sentences. So you could
there is an order. You see, the first one tells you about where it comes from. So the axon membrane hyperpolarizing and from SD1, which is the higher level, this is now SD 1.1. So it zooms in SD 1.3. So this is SD 1.3. You can see it in blue here on the left. This is the list of subprocesses that are, see, the K+ out of neuron flowing, axon membrane potential dropping, and axon membrane hyperpolarizing and recovering, which occur in that time sequence, because within an in-zoom process in OPM, there is a timeline that goes from top to bottom. So this happens first, and then this sub-process. And when this sub-process happens, you see there is a requirement that the voltage-gated K+ channel be open in order for this process to happen. So if I hover over it, it says K+ out of neuron flowing requires voltage K+ channel at state open. And okay, and so you see what happens then to the K+. It goes from the neuron to the extracellular fluid, but on the condition that the voltage-gated K+ channel is open. And the axon membrane has to be in the state depolarized. And at the end of the third sub-process, it gets repolarized and resting. So there is a cycle here that keeps going on.
So there is a loop, because
right.
then we go back to the start again. Okay.
And I also started. I don't want to keep you and the audience too much, but I also started modeling what happens, as I mentioned, if things go wrong and the neurotransmitters don't get released as they are supposed to because of some alpha-synuclein, which is a protein, does not unfold or get clamped and stuck and cannot release the vesicles where the neurotransmitters reside. So that is something that I'm working on.
Mm-hmm. So it seems that there's still, well, not just still, like that there's a lot of future research that can be done using OPM in areas that are well, other domains, that you're using it for medical research, but also the application to ISO standards and contracts and areas of life where currently we have very unstructured documents that are not internally consistent, and then also sort of pushing science and medical science. Do you see where do you see the future of OPM and where like research should be done on it?
Well, I think that OPM still is even though it's published and you know about it and many people and you do a great job of publicizing it, it is still mostly under the radar for most of the world, and it should. I think, and hopefully you agree with me. Otherwise, you wouldn't do this interview with me. That it should be much more put into the public eye for people, enterprises, and private interested people to use. Some years ago, I thought it is so simple and so straightforward that it should be part of a package like Microsoft Office that people can just do conceptual modeling. Actually, I was a little bit naive. It turned out that people are not. It's not. There are many people for whom this doesn't come, even though it looks very intuitive and very straightforward and simple, only objects and processes and relations among them. People have to get the right setup, mindset to really get into this. And hopefully, by education that starts early, not at the university, but even at the late elementary school people classes or age, that you can use it, for example, to model the water cycle that young students learn in school, how the water evaporates and the clouds shed the rain and the rain goes to the sea and so on. We can make a very nice model with pictures and simulate it in OPM, and that will prepare students at very young age, pupils, to use it as a thinking tool, as a modeling tool that enhances their conceptual thinking.
Yes, and certainly all the young children sort of in my life, they love building things, Lego blocks, and this video game Minecraft, which appears to me almost like Lego but in a virtual world. And so children kind of get that you can build stuff out of building blocks, and just adding a layer where also let's describe the behaviors. Like it's a bit of a big step, but I don't think it will be too hard. And it's almost like if we could somehow make a combination of Minecraft, Lego, and OPM, you might have children playing with it for fun.
Right. So with AI, we can think about a system where a person, a child, talks to the computer and describes something, some phenomena, some system, and right away the OPM model pops up with the graphics and the text and the animation already starting to work on it with pictures. Again, like I said, as I showed, we have the ability to embed pictures into objects and processes. And so that could be a very interesting and nice direction for research. We are using it already at high school level, and because system thinking is really one of the things, we call it the 21st century skills. System thinking is perhaps one of the, not perhaps, for sure, one of the most, if not the most important skill that 21st century citizens and employees and people in general are expected to have. And this is something that is not so well developed and should be emphasized much more. And that is a great tool for doing this. We have shown and we have published a lot in the educational field about using OPM as a vehicle to enhance system thinking.
Yes, yeah. And yeah, maybe in your home country, like getting it added to curriculum. I don't know if you have curriculum for like different age children. They're supposed to be able to do a thing, and yeah, maybe the big goal would be 8-year-olds should spend at least half a day studying systems thinking by way of OPM.
Absolutely, that would be great.
So just scrolling through all these questions that everybody gave us. Yeah, we touched on the intelligence, and you spoke of how your PhD student currently is working on essentially natural language to OPM. Are there any other sort of cutting edge things that you'd like to tell the audience about, or even encourage them to go and do or go and study?
Yes, I think as most people who listen to it hopefully know, that there was a lot of hope that the generative AI, LLMs, will lead the way to artificial general intelligence, AGI. And people realized in the last 6 months or so that LLMs are hitting a wall, that scaling doesn't really provide the diminishing returns that are dying away by spending more and more money on hardware and increasing the size of the neural networks that are being trained. And the problem with generative AI is that it is a black box. It works on statistical principles, and so this is why it generates often hallucinations, which people hoped to overcome, but they are still persisting. And not only that, the explanations that are provided, if they are provided, they cannot be argued for. And the reason is that the statistical underlying nature of the neural networks upon which this is all predicated. And so in recent years, people have started to talk about the neuro-symbolic approach, which combines the generative learning, the LLMs, with symbolic manipulation, with manipulation of symbols. Now, what we advocate right now is a subset of the neuro-symbolic approach, which we call the neuro-conceptual approach, where the symbolic component is actually an OPM model that complements the great work and the often very astonishing work, even sometimes jaw-dropping work that LLMs can do, but also eliminate the drawbacks of it being a black box that cannot be explained and all the hallucinations that come along with it. Because OPM, by definition, gives you the cause and effect that is so missing in generative AI systems. And combined, they really have a synergy that can overcome all the problems. And so what we are currently trying to start is really to develop this neuro-conceptual approach, in which LLMs and OPM will be combined into a powerful tool that can provide the infrastructure for AGI, artificial general intelligence. And if people are interested, they are welcome to join the research team that we are having here.
Fantastic. Yeah. So with that, is that where you would be, the output of your AI is a OPM model?
That is still, not necessarily just the model. The model and the output of the LLM, which is text, are going to be combined to output a text and a model that together make sense and are verifiable and correct and can be argued for and explained. And again, I still think that the B model visualization and text coming together is very powerful because of the way our brains operate. The visual and the verbal modalities complement each other. And
Yes.
this is, by the way, this is the foundation of the multimedia learning that was suggested and is accepted as the current theory by, I think it was, I forget his name, Miller? No.
Okay.
Anyway.
Yes. Yeah. No, I think this is very fascinating. And I think because we've got this foundation of OPM, it's essentially ready to be use all these AIs to use it as the foundation, as you described. So Dov, is there anything else you'd like to say to the audience, or even questions to them? They sometimes write in the comments.
Yeah, everyone who has a question or an idea is welcome to email to me, Dori. You can use Dori@mit.edu. That's easiest.
Yep.
And I will try to answer soon.
Great. Well, thank you so much. It's always great to talk to you. And yeah, everyone should get their copy of either the book on model-based systems engineering with OPM and SysML, or the original one, the object process methodology. Probably get both. I've definitely given many people copies of it, so it's they're both very, very good. So yeah, it's great to talk to you, Dov.
Thank you so much.
Right, so that's our interview with Professor Dov Dori, all about object process methodology, OPM. What you do now, well, you should download the PDF notes, get them at the link below. Lots of more details of what we spoke about. You should buy your copies of the books, Object Process Methodology and Model-Based Systems Engineering with OPM and SysML. You should check out the training courses on OPM, and you should, just be using more of it and actually apply it to your work. As ever, leave some comments below and I'll take a look at those, subscribe, and see you for the next one.